Hello everyone. This is a video that I'm putting together to give you some help and guidance on measuring formant frequencies as part of the lab assignment in our speech acoustics class. And so let's start just by reminding ourselves, reviewing what we're trying to do here. In this assignment, the first step, and I'm going to assume that you've done this already, but well, you need to make these recordings first. First step is to make some recordings, and what we're doing is getting two different adult talkers, one male and one female, to produce these 7 vowels in the context of these words. So you're going to get a male talker, female talker, and you can be one of those talkers if you want. Use yourself and a friend, and you are going to say the word heat, hoot, hat, hot, hit, het, and above or among. And so these words vary in the vowel in the middle, or they've got the schwa as the first vowel in above or among. And what we're going to do is measure the F1 and F2, these two formant frequencies for these 7 vowels, and we're going to contrast those formant frequencies for the male and the female talker, as well as a 7-year-old child talker, which I have already provided for you. So one more step before we get into clicking run in Praat, I want to highlight some normative data that I think are going to be really useful in guiding your expectations. You're going to be looking around in the spectrum, looking at the LPC formant solution that's trying to identify these formants, and it's really good to kind of have an idea of what to expect. And so this lab assignment has a lot of parallels with a study by James Hillebrand and colleagues. And what they did was they recorded men, women, and children producing these words. So heed, hid, head, had, hod, and hood. And there was a couple of other ones. I've just highlighted the ones that have closer correspondences to the words that we have. So our words have just voiceless consonants at the end. So instead of heed, we've got heat. Instead of hid, we've got hit. Head, het. But the parallels are pretty clear. And so what they found with this chart, and this chart is going to be your friend, is in each of these columns is the different vowel that belongs and that's part of this word. And then within each of these clusters of cells, you've got the men, women, and child values. So this first column is the duration of the vowel. We don't really need this right now, or for this lab. This next column, F0, this is the fundamental frequency, sort of the pitch of the vowel. What we really care about for this assignment are the values for F1 and F2, so the first formant and the second formant. And so for this example, for this vowel E, as the E is in heed or E is in heat, the male voices, the men's voices have an average F1 value of 342 hertz and an average F2 value of 2,322 hertz. Women, the formants are higher, 437 by 2661. Once again, and there's higher still in the child. So you have different F1 values and different F2 values for the same vowel, E, that varies across talkers. And so these, well, I should emphasize that these are mean values. This is the average for each of these groups. And if we look over in this scatter plot on the left, this is a standard vowel space plot. We have first formant plotted here on this x-axis, second formant, F2 on the y-axis. And so all of these red E's are instances of this vowel, and this is actually produced by 46 men, 48 women, 46 children. And so what you see is the average value of 342 times by 2322. It's somewhere in this middle of this cloud. But there's an awful lot of variability. And so this is really meaning the formant frequencies, the F1-2 pairs for the E vowel, they're generally in this neighborhood, but they're not all in one spot. And so we just need to be aware that that the recordings, that the numbers that we're going to get from our male talker or female talker are likely not going to be exactly or even very, very close to these values in the chart. But this chart is useful because it tells you where to look. We can kind of get a sense that for the vowel E, the F1 is going to be in the 300s, and we can look at the cloud. And so we're very unlikely to find an F1 value up around 1200 hertz. And if that's what Praat is telling us, then there's some issues that we need to fiddle around with the Praat settings in order to let it tell us values that are more reasonable. And so I'm bringing this all up first because this is going to help guide our expectations about of what these formant frequencies are going to be for our different talkers, and we can use those expectations to guide what's being displayed on the screen in order to give us more valid and relevant numbers. Okay, so next step, let's open Praat. So I've opened Praat already, and I have two different wave files. This first one, Nora Vowels, is the one that I have that I posted on Canvas for you to download. My daughter saying these vowels, and I've quickly recorded myself saying these words as well, just so we have an adult voice to talk about or to examine in this demonstration. So I'm going to select this object and view and edit. Okay, so depending on what you might get, depending on how Praat is set up, you might have nothing but the waveform and the spectrograms. So let me play this.
Heat, hoot, hat, hot, hit, het, above, among.
Okay, so let's zoom in. I'm going to select a vowel, and if I define a range and go select, we can look at it up close. And so immediately we see these vowels here, these bands of dark energy, and if it's not already shown, you want to go into this formant menu, select show formants, and what you're going to see are dots. So these dots are the Praat's estimates of where those formants are, and it's actually giving formant estimates where there actually isn't really much of a vowel. So if we play this,
Hat.
like it's giving you points. So let me just say first that so we have a dark red line, a line of dark red dots, and then pinkish dots. And what it's doing is it is alternating between red and pink, just so that we can kind of keep straight which one is which. So first formant, second formant, third formant, fourth formant. And so another couple of things we see in this waveform. So this first part of the wave, this first part of the sound, is really that that breathy huh. If you play it, there's no vowel there. What we really want to look at is this section here. Okay, now let me go back. So you can tell I've already played with this. So the formant tracks that you're seeing are going to be really influenced by some formant settings that you can change. So in the formant settings, you have a number of different measures. The formant ceiling is sort of the highest for you. So we're telling Praat to look for formants within a range of frequencies from 0 up to a formant ceiling. And so the way it's set now is it's looking for 5 different formants within a range of 0 to 5500 hertz. This is the default setting. It also has a window length here, and this is related to the increased spectral resolution that we get with longer windows. So we get more frequency resolution. So these are just the default settings. We can change, for example, the window length to, instead of 25 milliseconds, to 40 milliseconds, and we apply this. And what you see now, once I've clicked it to 40 milliseconds, we have fewer dots in each of these lines, but the line that's created by the dots is a little bit smoother. Now, the way this is now, it looks actually pretty reasonable. And I want to find some examples in which it doesn't, because that's where you're going to want most of the help. But and so you can see that this red line here is kind of plotting a path through this dark formant here. The second formant is plotting a path through this dark cloud here. And so how do you get these numbers? You can get these numbers in 2 different ways. You can simply just plot the cursor. If I move the cursor and click on a value here, I can look to the left and see that is at 841.9 hertz. And click on a second point further up, and you see that the second formant is 1639 hertz. So we can do this manually. The other thing that we can do is find a spot within the middle of this vowel, and it's a vowel because it's not including this aspirated H. We want this kind of voiced part in the middle. We select a point in time, go to the formant menu, and get formant listing. And so what the formant listing says is that at this point in time, at 4.865 seconds, which is the position of the cursor, right? 4.865 seconds. The F1 value is 841, and the F2 value is 1638 hertz. Okay, so let's remind ourselves of what this word was. So
Hat.
So this is the word hat. So let's look at the Hillebrand data. And so for hat, for male voice, the word hat or had, that vowel, has an average F1 frequency of 588 and a F2 frequency of 1952. And so let's see how we... So of course my data are not perfectly in line with Hillebrand, and that's okay. So we see that where the average data has a F1 frequency of 588, where I have an F1 frequency of 841. So we're off by like 250 hertz for F1, and for F2 we're off by 1952 compared to 1638. And so once again, off by a couple of hundred hertz. Now let's look at what, if we look at A, so this is this vowel A, the A and the E together is shown here as these blue dots here. And we see that even though the average F1 frequency is 588, which is around here, there's a huge range. It goes from like 475 up to like 800, or even more, up to 900. So my observed value is sort of an outlier, and that's okay. Similarly, if we look at F2, we're at 1952. Like my F2 value is 1638. And once again, I'm down in this lower range here. But I'm still in this general neighborhood. I would still kind of fit within this ellipsis. Let's try another one, and let's see if we get a little bit luckier.
Hoot, hat, hot.
Let's look at hot. Okay, so here is something where you see these two formants here. They're sort of overlaid a lot. They're really close to each other, and that might be the way they are. But we can look. There's a couple of things, and if you look at, if you click on Help, it actually gives you some clues on how to what are some of the more optimal settings. And there's a little bit of an art to this, or where you, not really an art, but you need to be adaptable and try and find settings that are going to give you values that make sense. And so here they're saying for a female voice, you want to set the maximum frequency to 5500 hertz. For a male voice, set it to 5000 instead. So let's see what happens if we set this to 5000. And if we can see, we have a little bit less overlap, and we could even, some studies will even do something where, in case let's say instead of looking for 5 formants within 5000 hertz, you might change this to 4 formants within 4000 hertz. And you see that these bottom ones didn't really change. But you can see them shifting around because you're telling it where to look, and how many peaks to find within a frequency range of a certain size. So let's stick with these values and find a point mid-vowel. And once again, we're going to go formant listing. And so we have a formant frequency, F1 frequency of 748, F2 is 1065, and all right, so what we're doing, we're looking at this vowel, the hot or hod, and hold on, let me get this back up. So we can look. So for this vowel, aw, in hot, the average value is for men's voice 768, 1333. My value is 748 for F1, 10,000 or 1065. But once again, that is going to be in the general area of this value. Lots of variability. So the male voices, and actually by default, Praat, the settings are set for female voices. But let's open up Nora's speech, because we might have to do something a little bit different for Nora's speech. All right, so this is the whole file. This is all the banter we had. And so let's zoom in. On this selection.
Heat. Hoop.
Okay. So I'm going heat. Okay. Now, these vowels, these formants look really messy, right? There's all these formants where there's actually not any really speech, but it's being erased, or it's Praat is being kind of forced to try and find formants even when there's no voicing. So these values don't mean anything because there's no actual sound. This is background noise. But right in here in the middle of the vowel, so this is the vowel. What we're interested in is what's happening in this chunk of sound. So here we've got by the default values, this is F1, F2, F3, F4. Now, the formant settings we have for a child are going to be different than the formant settings for an adult. So the frequencies are going to be higher. And so there are different recommendations. Some people actually are recommending going up to like 8,000 hertz. So find, let's say, 5 formants under 8,000 hertz. And if we click apply, see what happens to these values. Right, what we've done is expanded the range because, let me put this down. Let me put this back just to demonstrate. Okay, so as it's set now with these defaults, it's trying to find 5 different formats, 1, 2, 3, 4, 5, that are within a range of 0 to 5,000 hertz. And the problem is that the formants for child's voice, for child's vocal tract, that's smaller, and because it's smaller, the resonant frequencies of the vocal tract are higher. The formants for the child are going to be higher up. They're going to be outside, above that 5,000 hertz range. So but Praat is trying to find formants and kind of cram them into this 0 to 5,000 hertz range. If we increase this to some high value like 8,000, what it's doing is it's allowing those higher frequencies to kind of be where they naturally are, outside of that 5,000 hertz range. And we also see some overlap. The 2 and the 3 are sort of overlapping. Let's try this a little bit differently. Okay. So here I'm telling it to find the first 3 formants with a 0 to 6,000 hertz range. And this actually looks much cleaner, right? We have this one line here that is that this makes sense. This line of red dots kind of corresponds pretty nicely to what we see visually in the spectrogram as this first formant, and the second formant corresponds pretty nicely to the second formant. Okay, so let's click through this, and we can find some spot in the middle of the vowel, and we tell it to get the formant listing. And so here we've got, so this is for, I think we're talking about heat, right?
Heat.
Yeah, the vowel E. All right, let me. Okay, here we are talking about this vowel E, as in heat, and now we're looking at F1, the child's F1 frequency, so the average child's F1 is 452 hertz, and F2 is like 3,081, and so what we see, Nora's F1 is 387 compared to 342. Her F2 is 3785 compared to 3081. But once again, it's in a nice range. So if we were to plot the 387, F1 is down. 387 is around here on this x-axis, and 3785 is like up in this upper range here. Is just above this cloud of red E's. Now it's likely the case that her formants are higher because she's 7. She's smaller. The children in this study were like 10, 11, 12 years old. So they're a little bit bigger. But yes. So and once again, my point in bringing up this, showing this normative data is definitely not to cause stress, to think, oh, I'm worried because my frequencies are different than what the table says they should be. I know they're going to be different. The point of this table is to kind of give you a sense of where to look, and how to maybe adjust your formant settings to have values that are reasonable. All right, and the other thing that's in this study, and this is sort of relevant, what they've done is plotted the average formant values for these different, so here we've got E, and they're comparing this present study with a solid line to a classic study by Peterson and Barney, was one of the first vowel space studies. This is like Peterson and Barney, I think it's 1952 or 1954. And so what they're doing is they're comparing the average values for men, and you can see the F2, the F1 and F2 values here, and they've plotted it. F1 is on this on this y-axis, so it's going down. It's going from low to high, and the second formant is going from low to high on the right. And so you can see that, so in the present study, the average value is here, and you can see just how the scale has changed. Like, even though these figures kind of look really similar, so for the men, women, and children, the way that they've plotted it sort of undermines that difference, because you can see that for the child, the child's second formant, the scale goes from 800 to 3200, which is a much wider range. These E values, these formant values for E are actually much higher, even though they're in the same kind of visually they're in the same part of the corner. Here it's only like 2300 hertz for this E for F2. Here it's like 3200 hertz. So yeah, one of the things I'm asking you to do for your assignment is try and plot these on the same axis so we can see how the vowel space is stretched for men, women, and children, depending on their vocal tract length. And here they've sort of zoomed in on those points to the same degree so they fit within the square. And so I'd like you to avoid doing that. Okay, so this is basically how you do it. You're gonna need to experiment a bit with the values, and try and find values that make sense in terms of the general neighborhood that you expect for these formant values, and that makes sense in terms of what you're seeing on the spectrogram. Like this makes sense. We have this nice dark bar here for this. Visually, if you didn't have the formant frequencies, you would naturally say, okay, yes, there's a formant here. You can see that it's dark, and there's a formant up here. And so you want to get dots that sort of correspond to what you're seeing with your eyes. All right, I am going to stop now and upload this. Good luck.